Ladies and gentlemen, please. We are pleased to welcome on stage Marc Marano, President of EMEA and Americas region of Westinghouse, to host the Westinghouse panel discussions. The issue is safety, quality, and project delivery certainty, key ingredients for any successful major project. Thank you for your attention.
Good afternoon. It's my pleasure to be here today, and I really want to welcome you on behalf of Westinghouse for this panel discussion. I think you'll find it hopefully very interesting for you all. As was stated, I'm the President of the Americas and EMEA, which is Europe, Middle East, and Africa for Westinghouse Electric Company, based in Pittsburgh, Pennsylvania, and today I'm your panel discussion chair. First of all, Westinghouse is pleased to have this opportunity to chair this panel discussion, and I hope we all meet your expectations. So first, we will consider the emerging challenges and opportunities our industry is facing as nuclear construction projects near the conclusion in Europe, US, and Africa, and Asia, planning for new plants in established and newcomer new nuclear nations reaches advanced stages. We have a distinguished panel here today from all across the globe, the energy industry, who will draw on their expertise and share their insights and analysis as they move through their presentations from major projects on the operating fleets they're involved with and new nuclear plant construction, just not new nuclear plant construction. Each panelist will give a short introduction of themselves, followed by an 8 to 10 minute or so presentation, and then we'll follow it up with Q&A. It's my pleasure to introduce our first speaker. I'm pleased to introduce William D. Magwood, IV, the Director General of OECD and Nuclear Energy Agency, NEA. Bill?
Good afternoon. It's good to see all of you here today. People interested in building new nuclear power plants. How many of you have actually built a new nuclear power plant? Raise your hands, please. I see one hand. Hire that man right away. Because that is actually one of the biggest challenges, I think, facing new plants in this modern era. We've recently completed a report on nuclear new build, which you can obtain from our website free of charge, and you can see the details of this report. But this report did an analysis of various nuclear projects around the world, looked at the history of nuclear construction projects in recent years. It's been 56 plants built and operated since the year 2000. So there's a lot of data out there to look at. And we also talked to a lot of experienced people to understand what some of the challenges are. And I wanted to highlight a few things. As I mentioned, having experienced people has proven to be one of the most important challenges. Building a nuclear power plant, as you can guess, is not a simple matter. It's a very complex project that requires not just a lot of resources, but a lot of experience to know how to put the pieces together the right way at the right time. As we go forward with building plants in this new century, we're finding that the experience base of people who've actually led these large complex projects is actually quite thin. There are actually very, very few people left that have direct experience in nuclear power plant projects. And this has had a significant impact. If you look at the projects around the world, you see a mix of very good stories and not so good stories. In some cases, you see cost overruns, you see civil construction mistakes, you see a lot of rework. In other cases, you see very smooth projects being accomplished more or less on time and on budget. The biggest difference, I think, is experience. Some manufacturers have had the opportunity to have a continuous build program. A very good example is what we've seen in the Korean program. Multiple plants being built year after year after year, so you have a very large cadre of experienced managers that can lead projects. There's other examples as well. We see that developing in China today. We see it in Russia. We see it in a few others as well. But in many countries, we haven't been building plants consistently enough to gain that experience. And that's actually something that's a big challenge for all of us. And it's not just the leadership of the projects, it's also the contractors and subcontractors and sub-subcontractors that don't have the experienced people to lead projects. And that's something we have to deal with. We also are dealing with an age where electricity markets are very much disrupted. Electricity markets are not supporting baseload power plants anymore. In some markets, it's impossible to invest in anything unless you receive a government subsidy. In other words, we have a lot of parts of our developed countries where the electricity markets simply don't work. They're dysfunctional, they're broken. And it's impossible to build a large nuclear power project in a broken market. There's no way to make enough revenue to justify a new project. And in some parts of the world, the prices are so low, you can't even continue operating nuclear power plants that exist, and they're fully depreciated. That's a serious problem. And it's a problem that I think the governments all around the world have to look at very closely before it's too late. We've already seen, both in Europe and in the United States, nuclear power plants will be pushed to the edge or actually shut down because of these financial issues. They have nothing to do with the nuclear power plant themselves, but have more to do with the disrupted markets. So as we look forward, there's things that we can do, and there's been some innovations that we can take advantage of. At the NEA, for example, we have under our umbrella the Multinational Design Evaluation Program, which is an organization that brings together regulators from around the world to look at new nuclear technologies and try to find more efficient ways of assuring that we have the highest levels of safety around the world. This has been quite successful. Regulators today are much more in communication with each other, have much more cross-fertilization than they've ever had in the past. And NIMDEP is a great example of that. But I think that we may need to go further in some cases. There's been a lot of discussion in this conference already about small modular reactors. Small modular reactors could benefit dramatically from much more coordination among global regulators. It's something that we are talking to our member countries about right now, and I think it's something that could be very, very important if small modular reactors are to be used widespread across the globe. Another innovation that we've been thinking about, which requires a great deal of work, is finding greater opportunities to standardize global codes and standards. Across the world, we are not consolidating codes and standards, we're actually seeing them proliferate. We're actually seeing more standards being proposed and being developed instead of consolidation. If this trend continues, we'll have such a fragmented situation for the nuclear industry globally, it'll be very, very difficult to build one design in multiple countries, which is what we need if we're going to see these designs become cost effective. So there's work ahead, but and as I said, there's both good news and bad news. I think the good news is that if you look at the actual environment we're operating in, an environment where electricity is expected to grow dramatically over the next few decades, an environment where CO2 emissions are under scrutiny, an environment where long-term, consistent, reliable supply is necessary for economic growth, that's an environment that should see nuclear power plant thriving. But instead, because of mostly policy and political decisions made in various countries around the world, we're seeing the exact opposite. But I think that you'll see a correction eventually because, as you know, the principal job of those who produce electricity is to keep the lights on. And I've noticed that when the lights go off and the air conditioning goes off, people get annoyed. And I think that we are going to see that governments are going to respond to the need for consistent, low-cost electricity, and nuclear power can play that role. But there's a lot of work ahead of us. So with that, I'm looking forward to any questions you have and to the discussion this afternoon with the panel. Thank you very much.
Thank you, Bill. So it's my opportunity to talk about Westinghouse's view of major projects, and as you can imagine, I will talk about our progress on the AP 1000. So, I think many know that Westinghouse is founded on innovation. Back to our founder, We're proud of our technology, and we're really proud of our advances on the AP1000 for sure. Not only just AP1000, we've had advances on major project work and operating plants and new technology that we're developing, and those go on simultaneously as we advance the AP1000 at our 8 sites that we're working on, 4 in China and 4 in the US. But it's a significant innovation advancement for us, and I'm going to talk today a little bit about lessons learned, how we have advanced the ball. The good thing, as you know, sometimes a challenging thing when you're one of the leaders, you get a lot of attention, you get a lot of press, and we're at the point in time in our construction of these projects that we have moved through those points and are really pleased at where we advanced our new plant construction with our customers and our partners. So if you look at it, there was 3 things that we needed to address as we went through the AP1000. First of all, proven technology, innovation around passive safety systems. I think it's proven itself in the post-Fukushima era to be the right choice of technology, and we have moved through construction unwavered even after post-Fukushima issues. And those issues largely ended up impacting a lot of the operating plants, but we just moved forward with our technology because it was the right fit and form and function for what was needed before and after Fukushima. Regulatory certainty. Our NRC approved our design. We have moved through the regulatory process a number of years ago. We're advancing our regulatory process with the GDA process in the UK, and we think we are much further along and are really proud of that. And as a result, we had the opportunity to start real soon. Not only start in China, but also to start in the US. So our focus today is around delivery certainty. And for us to have delivery certainty, it required us to learn a number of things. I probably don't need to talk much about reactor coolant pumps. Most of anything I would say was in the newspapers or in press releases. Not all of it at all times 100% accurate, but the reality is we have moved past that hurdle, and we advanced that as we move through the nth of the kind and delivery of our AP1000s. Our experience in doing this has been outstanding. I think as Bill mentioned, the skill and the resources to do these projects are ones that challenge any project, specifically on building a new power plant. Project director roles at these sites are demanding, and they're the most seasoned, experienced folks you can find. We've been through a process where some of the project directors have changed over, just because after 3 or 4 years, it's a very demanding and stressful task. But those folks are the ones who have allowed us to advance our technology, and we're real proud of that. And our customers recognize this, so we worked hand in hand with our customers in the US. As we move through this, you learn that you're going to have to recognize that you need those experienced folks, and you need to make sure that you're prepared for changes as you go through the construction, not just the technology evolution, delivery of equipment, and the supply chain. That was all part of the lessons learned incorporated in delivering and moving forward to AP1000. We have made improvements in several areas. The CA20 module, we've learned how to set that with a laser process now, and we've eliminated all interferences as we've moved through in the US. We learned through that in China. Great learning experience for us. And with the 8 units going on, each of the units are benefiting from one another. And I think as a result of that, we have learned a lot as a company and feel very comfortable when the next set of AP1000s are ordered, eventually ordered and delivered in hopefully in India and the UK, we will have tremendous lessons learned. So there's lessons learned such as the one I just mentioned that saves countless amount of schedule time that goes on a daily basis. If you think about the process, as I mentioned, this looks real simple. As you deliver more projects, you want to have a better schedule, more defendable, less deviation, just like on cost. But the certainty equation as you go forward, you want that certainty piece to be much more assured and viable. So I think there's a number of things we've learned in this process. We've had deviation in all these, but now we're in a position where we're able to be predictable as we move one unit to another. The reactor coolant pumps have been installed in Sanmen and in Haiyang. The duration improvement between the 2 units over 37%, and 11 days better from 30 to 19 days. That's a significant improvement. And the reason you learn that is you do it once, you do it twice, and then you take those lessons learned and you implement them in the second units in China, and you implement those lessons learned in the US. We've learned in shield building fabrication. We've improved that over 30% from the initial first-of-the-kind evolution. And as a result, we've taken these lessons learned and we implement them as we go forward on our projects forward. And I think it's really impressive to realize that these are the things that people don't necessarily hear about. And as a result, it's allowed us to advance to a point where we're real proud of where we're at. And I'd like to show you a quick video just on the Sanmen site progress to give you an idea of a time elapse of how that plant has come along in sight. And just to give you a sense, in Sanmen, we have completed cold hydro, and we are planning hot functional tests around the July time period. And our expectation, along with the customers, is that we will load fuel in the fall of this year and look at commercial operations in 2017. And as you can see, it's a pretty impressive process. This is a real plant. When you visit the site, it's a plant getting ready for operations. We're getting ready for fuel. We're getting ready for the engineering and fuel loading to take place. We're at a plant where we're going to turn this reactor on. That only comes with lessons learned and commitment from folks who are at the site and along with the customers, and the willingness to be patient. The easiest thing to do is when you have a problem through a first-of-the-kind construction is to not work together. I think we worked through that and effectively are going to deliver the AP 1000 for Sanmen 1. What's interesting is the lessons learned have been so significant, Haiyang is very close behind. They're going to start cold hydro here real soon, and then subsequently after that, functional test. And there is an expectation in a year or so, plus or minus, probably a little plus, we could be looking at 4 operating units in China. And with the expectation that the units will be delivered in the United States in 2019 and 2020 with our customers in the US, Southern Nuclear, and South Carolina Electric and Gas. So I want to leave you with the point that this is what it looks like when you get through all the fray. The lessons learned, if we had our project directors here, you would be amazed. But the reality is we have fought through all those challenges, and as a company, we remain resilient. We work through commercial issues. We work through legal issues in the US. We solve those problems while continuing construction. I think that piece of the equation is not talked about. The commercial part of a nuclear power plant is very difficult. And it's one that requires the customer and yourself as a vendor to work together. A contract is one thing, but the relationship when you're putting real metal in the ground and what you're really trying to do and how important it is to the industry, especially given the industry and the stress that we've been on due to the economics, makes us real proud to be part of these construction projects and eventually operation of the AP 1000. One thing I'd like to leave you with is we do the same thing on the operating fleet. We do major projects and significant innovation on the operating fleet. And I think you'll hear from one of our panelists on a tremendous lesson learned that we learned with them on a project. I won't steal his thunder, but it was a great experience, much smaller than building a new nuclear power plant. He's probably smiling over there. We had a lot of difficult discussions at times, but ultimately we got through it. So just like that project and just like the AP 1000, we're really proud of it, and hopefully the world will see when we go operational that it's the next advance of a new nuclear power plant. Thank you. Tom?
Thank you, Mark. Good afternoon. My name is Tom Samson. I'm the Chief Executive Officer of NUGEN. It's a pleasure to be here at the second WNE in Paris. Particularly grateful for Westinghouse hosting a panel on a topic that's very close to my heart in NUGEN. Safety, quality, and delivery certainty is key ingredients for a successful project. There's certainly elements we need to get right for NUGEN to succeed. A little background on NUGEN. We are owned by Toshiba and ENGIE. We are a nuclear new build program in the UK. and we are responsible for developing and delivering 3 AP1000 units in Cumbria as part of the UK government's ongoing commitment to refreshing their energy mix and committing to energy security and climate change with low-cost, affordable power in the UK. Our aim is to have 3,800 megawatts of nuclear baseload power on the grid by the mid-2020s. We're based in Manchester. We're about 130 people today and growing. And we're also currently on site in Moorside in Cumbria, undertaking one of the largest geotechnical investigations in Europe to determine the ground conditions for our facility. Our wider development efforts in NUGEN are continuing at pace. We have launched our second stage public consultation this summer, and in the middle of that, our GDA process with Westinghouse and with the ONR in the UK is making progress towards receiving the GDA at the end of Q1 next year. And that development progress is focused on moving us forward with confidence to achieve our final investment decision by the end of 2018, and then onwards to bring the reactors online by the mid-2020s. However, in the UK context, we are at something of a crossroads. We have an aging fleet of existing nuclear plant, we have a deep commissioning legacy in Sellafield, and we have an emerging excitement around the SMR programme. And yet we're still confronted with the financing challenge of building a new fleet of nuclear baseload reactors in the UK. Overcoming that financing challenge is a crucial first step on this journey, and then as an industry, with our partners, we need to rise to an even bigger challenge of delivering those new build projects on time and on budget. As Bill's already mentioned, the consensus view is that the electricity markets are broken across Europe, and the conditions for investment in new nuclear are extremely challenging without market reform. Fortunately, in the UK, and we haven't said that very often in the last week, but fortunately in the UK, they're leading the way in implementing a solution to that market barrier by delivering a contract for differences regime to facilitate investment in nuclear power. They're also providing support in terms of government support for other funding sources. At NUGEN, we're also focusing on that financing challenge by trying to solve the funding solution with debt. We're exploring export credit agency solutions to bring debt in to help fund those programs in the UK, and importantly, structuring EPC solutions which are focused very much, as Mark has said, on delivering and capturing those lessons learned from previous projects where we can hopefully successfully plan and deliver these plants on time. The UK drivers for nuclear new build are really driven by two key factors. The first is security of supply. By the end of 2030 in the UK, there will be a single generating reactor in the nuclear fleet, and possibly all of our coal plants will be shut down. So there's a strategic imperative to fill that huge gap with baseload nuclear power. It can't be solved by renewables, and if we look to combined cycle gas turbines to fill the gap, we have to make sure we have a source of gas to rely upon for that future operating regime. So nuclear new build is a credible way to fill that gap, and the UK energy policy is firmly focused on that outcome. The other reason why nuclear new build is such important to the UK at present is climate change. Nuclear power accounts globally for about 11% of the UK's the global production of power, that contributes about 40% to the world's carbon abatement effort. So if we're wanting to make a meaningful impact to climate change, then we have to do so by delivering new build in the UK. Let me talk about the three key elements which have been raised today as successful ingredients for nuclear new build programs to be delivered. The first, in terms of safety, it's really important to reflect on the journey we've gone through as an industry in the past 50 years. The original designs that were put in place back then at the start of this industry have stood the test of time and been able to enjoy successive life extensions whilst maintaining their safety margins. Regulators globally have been steadfast in their ability to implement robust regimes to ensure the highest levels of safety across our industry, and the Gen 3 design solutions have continued to learn and evolve from industry experience into far superior products that make us well placed for the challenges ahead. Finally, in terms of safety, we should also acknowledge the progress that's been made with governance and leadership as an industry as we seek to challenge ourselves from our peers and pursue excellence and best practice from elsewhere so that we can strengthen our own capabilities. In terms of quality, I think the industry has more to do when it comes to the growing challenge around CFSI within the global supply chain. This isn't just a regional challenge, it's a global challenge, and we must do more to fight against these issues by having deeper, more intrusive quality programs that dive into the supply chain and ensure the integrity and veracity of the testing regimes. As Mark has mentioned, the final issue, project delivery certainty, that is a really important, meaningful way for us, particularly in NUGEN, to instill confidence in investors. We have to be able to measure that delivery certainty, and we do that by trying to quantify delivery certainty by doing some of the things that Mark has mentioned. We have to look at the why for every delay. We have to get to the root cause, and we have to make sure that those experiences are built into future projects by mitigating those experiences in the supply chain, in the engineering space, and in the construction space. We have to monitor the supply chain to make sure that we understand who can deliver, who can perform, and who's got a proper track record on which we should build the future projects. We also have to look to an experienced workforce to transfer that knowledge, especially in a global context, into new markets or regions, and select partners who've got the track record of delivery and excellence. I know that from a NUGEN perspective, delivery certainty is not just something that we talk about. We have to measure it, we have to demonstrate it if we are to make any headway in providing investor confidence. So in conclusion, NUGEN are powering ahead with confidence that our technology, with the AP1000 from Westinghouse, our shareholders with the support from Toshiba and Onji, and our teams in Manchester and Cumbria have the creativity, the energy, and the ambition to deliver on our vision to provide clean, affordable nuclear power to the UK. Thank you.
Okay. Hi, everyone. Ladies and gentlemen, good afternoon. I'm from China, and I appreciate standing here to give a presentation. Happily, I will share some experience about what's the design role. What's the design role in the project's successful delivery. And I have three parts of my presentation. Let me start with the first part. In this part, I will show you some statistic data about the construction period of the nuclear power plant. And till now, more than 400 nuclear power plants is commercial operation, and we have collected a certain big data about the construction period. When we put this data together, we can find out it's very close to the Poisson's distribution. And the average month is 66. So, so we can find out that if the units have more loop and have more power, it means the type of the unit has more complexity. So we need to cost more time to build this construction. So the construction period has obviously positive correlation with the complexity of the nuclear power plant. With more than 30 years nuclear industry development, China has accumulated more experience about the nuclear industry, and the construction period for the China units is shorter and shorter, and steadily close to 60 to 65 months. It's strongly support for. It's only because strongly support from the country source, and we can find out the skilled workers, the bulk materials, also the broader use of the machine is benefit for the project to be more shorter. So, how the designer play an important role to the project success we should reduce the complexity of the nuclear power plant. For developing a new nuclear power plant, when we, in the design stage, we should consider the simplified, modularized, and integrated. This principle should incorporate to the design concept. And in the engineering designing, we should focus on the adaptabilities, and we should fully consider to convenient to each parties of the project. And the third is the designer should provide the strongest service to the project, so the designer can contribute to increase the possibility of the project success. Now, in the second part, I want to show you 4 topics. First is balance. We always caught in the middle between the design margin and the economical considerations. So the balance is important. There's a Chinese saying, chasing the deal in spite of the rabbit. It means we should grasp the more important thing rather than the less worse things. And I try to give an example about the first-of-a-kind project. We summarize the 3 C principles for the FOC project. First is the commercial. For the project success, it's not only the delivery of the success. We should consider the demonstration effect of the project, and also we can make the potential market from this project. The second is the contents. So for each section of the FOC project, it has more risks than the normal project. So we should consider more design margins to solve all these risks. And the third is the concept. As I said, the simplified, standard, modularized principles should be used in the concept design. And this will ensure the new developed type unit has the inherent economy. And for the detail design, I think we should not pay more attention, maybe over attention to the detailed design. The second topic is standard design. It's a hot topic. There's a Chinese saying, draw a groove according to the pattern give. But the truth is, draw the scoop according to the groove giving. So ideally, we think the standard design just like the copy machine. We using the same design, same equipment, and we provide the standard product. But the fact is, when we do the project, we will facing more difference and more risks from the other sides. So we should carefully solve all these risks. The third is why export projects always have a long time to the domestic project. The key factor is, there's a Chinese saying that the taste orange growing in the southern China would turn sour once it is grown in the north. So the key factor of the export project is adaptability. We should consider the adaptability of the national conditions, including the laws, industry level, and industry laws, and also the human resource. The fourth topic is the design service. The design service can bring the strong value to the project. When we do the design service, we should, for example, we should review the equipment documents, drawings. We should do some design clarification to the construction and installation contractors. Also, we can participate to the commissioning. So with such strong service, because all the parties of the project is around realizing the design's requirement, so the designer can make great contribution to the project success. The third part, I shall want to talk about some further considerations about success. The key word is the value creation. when we do the project success, we not only consider the project delivery, we should consider the model success. The model success is more important than the project success. It means it will bring the brand effect. It will make the progress of technology. It's also benefit to the whole supply chain of the nuclear industry. And the second is we should have the capability to discover the value we may ignored before. As Chinese ancient Lao Tzu said, we work with the being, but the non-being is what we use. So meet the owner's requirement is we purchasing none, but we should consider how to guide the owner's requirements. We may not only provide the nuclear plant, we may consider how the requirements of the lifetime extensions and the decommissioning of the nuclear power plant. So this will be dig out the extra value of the project. The third is it is true that standard design is we always facing the situations that the custom will raise many requirements. So the customized design is a way we try to, but due to the huge cost of the customized product, and we only can provide the standard design. So how to find a way to solve these problems? I think we are on the way, and to using the digitalized and intelligent design system. This may be more efficiency and more accuracy, and maybe benefit to the low-cost customized products. That's all for my presentation. Thank you.
All right, good afternoon, everybody. I'm Scott Greenlee. I'm the Senior Vice President for Engineering and Technical Services at Exelon Corporation in the United States. And what that means is I have engineering, I have fuels, and power uprates, among other things. And Exelon is currently the largest generating company in the United States based on delivery to households. And we're also the largest operator of nuclear plants in the United States. We operate 23 nuclear plants. Unfortunately, as one of my panel mates mentioned, the energy markets are pretty much broken in the United States, and we just announced the shutdown of 3 of our nuclear plants because it's not cost effective for them to run. So what I'm going to talk to you about today is a little project that Mark Marano alluded to. This was a power uprate we did at our Peach Bottom nuclear plants. These are 2 fairly large boiling water reactors. We uprated them by about 300 megawatts. And the big challenge on this project was the steam dryer. So I'm going to talk specifically about the steam dryer, but I'll also add on to a couple of things that Bill and Mark said, and I think some others mentioned, is that one of the big important aspects of this project, and it was a very, very large project done in a very short period of time. The fall outage last year, we did it in about 30 days, and I would say we probably did as much work in 30 days as anybody has ever executed in the United States. Pretty much done flawlessly, and it was done that way because we picked a very, very experienced team who had done uprates at a lot of our units. So the experienced team was really what came together to make the outage a success. So the steam dryer, and for those of you who don't know what a steam dryer is, in a boiling water reactor, you have a very large piece of metal inside the reactor which takes the moisture content out of the steam before it's delivered to the turbines. And you can see here kind of the timeline we were on for this project. We started back in 2009, but we didn't actually approve the steam dryer work and award it to Westinghouse until the 2012 timeframe, which made this a fairly fast-track project. And what you can see on this slide as you get down to the bottom is we manufactured the dryer and we test fitted it in the first one in the late 2014 timeframe, started the unit up in December of 2014, and you can see down at the bottom, we did not get Unit 2 to full EPU power until May of that year. And we didn't get it to full power because of some mistakes we made along the way, which is really what I'm going to talk about is if we were to go back in time, what would we do differently to prevent that 5-month power escalation period because of the mistakes we made with the steam dryer. I'm not going to cover this slide because we don't have a lot of time. This just kind of tells you what the overall scope of this steam dryer project involved. But I will mention that part of the project involved taking out the old dryer, cutting it up underwater, and then putting it into large canisters and shipping it off-site. And actually, we never got it off-site because of the dose rates, but so it's still sitting on the site. But you're going to see some pictures of that, so I thought I'd mention it. Okay, so here's what the steam dryer looks like. It was a new design for us. The old design was circular. This design was based on the Westinghouse Nordic dryers. We thought it would be an exceptional piece of equipment, and it really is. But the mistakes that we made along the way were the original design concept was to have 300% safety margin. So the stress ratios are the key on this dryer, because if the stress ratios get less than 1, then you're stressing the welds in the dryer, and the dryer can actually come apart inside of the reactor vessel, which has happened at another nuclear plant, which I will not mention, but Exelon owns it. And where we upgraded the units, didn't do a good job on the dryer came apart, pieces of the dryer got into the main steam system, was not a good day. So we wanted 300% safety margin on this dryer. What happened was there was a analytical model that was used by a third-party vendor to calculate and design the dryer for those stress ratios that we wanted, and there was an error that we found in that model along the way. And that error was such that when it compounded with some other errors, which I'll mention in a minute, we actually had stress ratios less than 1 at one time. I mean, they weren't real, but that's what the model was showing. We had less than 1, which means, okay, we put it in service, we break the dryer. And the Nuclear Regulatory Commission wasn't real happy about the low stress ratios, because if we'd been up at 3, would have been no problem, but since we were down close to 1, the NRC was very intrusive in our project, and that's why it took 5 months to get the power. The other mistake we made was in shop fabrication. We did not actually get what we thought we were going to get out of the fabrication, and in particular, what happened was we did not do non-destructive evaluations on some of the welds, and when you do that, you have to take a penalty in the analytical model, which further compounded our stress ratio issues. And so those two things together, the error in the analytical model and not doing NDE in the shop as we had expected, gave us these really low stress ratios. And here you can see in the dryer just typical flow paths. On the right-hand side, you can see the steam going up, and on the left-hand side, you can see the water coming back down through the baffles that actually cause the water to leave the steam. And these are the next set of slides, just some pictures real quick. This is the steam dryer as it was test fitted in the shop. And this dryer is so big and so heavy that you had to deliver it to the site in 2 pieces, and this is the lower part of the dryer being delivered to the refueling floor at the site. And then this is after getting the upper dryer to the site, doing all the welding and putting it together, actually moving it to the test stand. It's a pretty neat piece of equipment, and I've actually crawled all over the Unit 2 dryer, very substantial piece of equipment. You would never believe you could get stress ratios less than 1 on something this big. But like I said, at one point we thought we had that. And of course, if you've got really low stress ratios, you have to put a bunch of instrumentation on your dryer to measure stress ratios when you get up at power. And this just gives you an idea about how much instrumentation we put on this dryer. It was a lot. These are the shipping canisters that I talked about cutting up the old dryer. These are the huge canisters that were manufactured specifically to get rid of the old dryer. And this is actually in the containment. We've actually put the piece of an old dryer, which we had some trouble getting cut up on the first one, into its shipping container to try and ship it off-site. Okay, well, here's the meat of what I want to talk about, and this is what were our lessons learned. And we actually learned some of these lessons before the dryer project had been completed, but not in time to really keep ourselves out of trouble. And where we started to learn lessons in the United States was with the San Onofre plant. And I'm sure some of you are familiar with the San Onofre plant. We call it SONGS. They ordered steam generators from a vendor, and the vendor did not do such a good job with the steam generators. Analytically, they weren't sound. And when they put them in, they started getting leaks, radioactive leaks in the generators, and those 2 units are permanently shut down because of that. And so what we have done at Exelon is, and you can see on the very top, it says owner verification of analytical results. And this links into WNE IER that some of you are probably working on right now, 16-9, called Risk Management Challenges. This was based on a previous United States IMPO IER, and the SONGS plant was part of that. So how do you prevent getting into a situation like SONGS, or how do you prevent messing up dryer calculation? And what we've decided at Exelon, and we have a pretty sophisticated process for analyzing the risk of every project we do, and if that risk can be what we call enterprise risk, which means it'll impact the company's bottom line, then we go to great measures to make sure we do not achieve a consequence that impacts the enterprise. So we look at the risk. If it's got enterprise risk, what we will do is either we have to completely independently verify the vendor's calculations and analytical models, or if it's a very complex model like the dryer model or like the SONGS steam generator, we do what we call a black box comparison. So we'll actually spend the money to go hire a separate vendor, and this all goes back to how you set your contracts up too, because you've got to get your vendor, like in this case Westinghouse, to share information with another vendor so that they can completely build a separate analytical model, and then you can compare the 2 models and see if they converge. We did not do that on the dryer, and it almost cost us dearly, but we ended up working through it eventually. The other big lesson learned that I just want to share is the fabrication of the dryer and the fact that we did not get the right NDE done on the welds, which created a penalty. What we discovered there was we did not go through and involve the design engineers adequately in our shop fabrication quality assurance program, because the design engineers would tell you, hey, I need to know exactly what the condition of all these welds are in order to make that analytical model work. And then if you link that up with the quality assurance program and the procedures, then you can make sure you get the information you need so that you don't get in trouble with the analytics. And we didn't do that, and that's where we got in trouble with some of our welds. And I think the last thing that I'll mention is the third-party model issue was a big problem for us. If you've got a vendor who's sub-vending out to a third party and your vendor doesn't really know the insides and outsides of that analytical model, it can become problematic if you have to revise the model. And in our case, we had to revise it extensively, take the conservatisms out in order to get those stress ratios where we needed them. And with that, I will turn it over. I got to go get, we have a bunch of other pictures in here that you can look at on your own if you want. Oops, there we go.
It's okay, I'm not drunk, honestly. Good afternoon, ladies and gentlemen. It's an absolute pleasure to be here this afternoon. Thank you very much to Westinghouse for inviting me along to speak on behalf of the National Skills Academy for Nuclear. We're a UK-based organisation led by 120 member companies in the supply chain. supported by the UK government to address the very big skills challenge that we have in the UK, and we very much share with the rest of the nuclear world. My name's Dawn Vinall, as Business Development Manager for NSAN. My role is a fantastic one. I get to come to places like this. Absolutely fantastic exhibition. Well done so far to the organisers. It's great to see so many of you here. I get to really talk to people about what their needs are, and I'm looking to the future. What's the market doing? And what, in terms of skills, is the future demand for skills? It's very much industry-led in terms of the sorts of solutions. I'm just going to show you a few of those now about how we're addressing our challenges in the UK. So what are those challenges? Well, for us in NSAN, the strategic agenda is set very much by the new build developers and by the existing site license companies, also by government, and we also work in defence, so the MOD is also part of this. And they tell us that it's about long-term skills management. There are some skills issues and challenges. We very much need to raise the public perception of nuclear in the UK, and I suspect that's very similar in your countries as well. We need contract security, and that's very important. I'll come on to that in a moment. Decommissioning careers, in light of the buzz around new build, there's a big market, a big industry in decommissioning in the UK and in other countries, and we need to also keep that profile in the forefront of people's minds. And hopefully, at the end, we'll have a few conclusions about some of the ideas that we have. I mentioned the skills challenges. We have an aging workforce, like many countries who have a developed nuclear workforce. There is a lack of diversity, unfortunately. The nuclear sector image amongst the public is quite mixed, and we need to do better to work with public and the media, really, to improve the image of the nuclear sector. Projects like the NUGEN project at Moorside that you've heard about today from Tom, fantastic for doing that, and that's really raising awareness not only in Cumbria but also in the rest of the UK about the power of the industry to regenerate, and also the low carbon energy message. However, there are other opportunities for supply chain in other sectors, other growth markets, so we have to balance the need in nuclear with the demands in construction in particular from other sectors and other projects in the UK. It's a very busy time. And of course, delays and uncertainty in the new build arena means planning for skills. It just means it's that more and more difficult. We don't want to train too many people too early, and they are then lost to the sector. We want to train the people in the right skills at the right time. So working with our member companies, our partners in government and other stakeholders, we've developed something called the Skills Lifecycle. You can see that up there. Hopefully it's clear. It starts with having an attractive sector to have the right public image. It's about enabling the industry to recruit and retain people from school leavers right up to people when they're leaving their careers, and how we can use that knowledge in the sector. It's about, number 3, addressing key pinch points, and what we mean by that are there are certain job functions that require pump priming in order to make sure we have the right number and the right quality of people. And we have been doing an enormous amount of analysis of the labour market intelligence to find those pinch points and put plans in place to address them. It's about professional development, continuing professional development, working with the higher education institutions across the UK and indeed across the world to make sure that we have the best nuclear professionals in the industry. That's a very important area. And we've also heard, indeed I have during the conference, about the importance of knowledge management and the transferability of knowledge, particularly with those exiting the workforce at the end of their careers from decommissioned sites into the supply chain and indeed the new build projects as they develop. So we have some challenges, but of course we have to have opportunities to counteract those challenges. We have got a government that is committed to, well, we won't talk about the government, we don't know about that just at the moment, but in terms of policy, we have an increased focus on science, technology, engineering and mathematics in schools. We have new entry routes, new apprenticeships coming. It is a sector of opportunity, and projects, as I mentioned, NUGEN and also the EDF project in Hinkley Point C is really helping to spread the awareness of the opportunities in the sector. And of course, it is about keeping the lights on, but it's also, and in particular for the younger generations, important to stress the CO2 reduction targets that we have. I mentioned new apprenticeships. Sellafield for the decommissioning market is leading the way on designing new apprenticeship frameworks. If anyone's interested in those, please do come and contact me and I can tell you all about them. We have an on-learn e-learning training network to spread these ideas and solutions, training solutions. That's what it looks like. That is free of charge for anybody to access. If you're interested in looking at some electronic learning for your own workforces, log on to nucleartrainingnetwork.com. It's a free portal, and you can have a look at what's available there. It's very important to celebrate success in the nuclear sector to balance some of the challenges that we have. We have invested very much in training courses in the UK to help introduce new people to the sector, people transferring in from other sectors such as oil and gas, to facilitate the free movement of people across the sector and the supply chain, and to enable companies to maximize the value of training so that they're not asking entrants to their sites or to their workplaces to repeat training that's been done elsewhere. That's called the Triple Bar Suite. Again, these things are available through the Nuclear Training Network if you'd like to have a look at those for existing sites in the UK, the nuclear new build sites in the UK. We have a triple bar for the manufacturing workforce, and we also have a joint program with the IAEA looking at nuclear security, very basic fundamentals that enable people to get a taste for the IAEA's expectations around international security. A really great success. Very recently in the UK, we've had the announcement that the government is funding the National College for Nuclear. This is an initiative led by Sellafield and EDF Energy, which will develop the curriculum for the sector of the future. 2 new centres of excellence in the southwest and the northwest expected. 40% of the activity in the nuclear sector in the UK is done within the supply chain. So as people have already mentioned, Mark and Tom in particular, it's vital that the supply chain has the right skills in order to fulfill the requirements of the new build agenda. Again, we have some funding to help that, so if there are any UK companies that don't know about our bursaries, please do come and talk to me. In terms of competence, this is an enormous area where we need to act. We have a nuclear skills passport system, which enables us to build competencies. This is a project management example. I'm whizzing through because I've got 2 minutes left, where assessments can be done online securely and reports can be generated for human resource development. And training can be sourced through this as well. So the recommendations from the gap analysis can lead to new training solutions. Celebrating success is key, as I've mentioned, and I now have a very short video to show you. Very, very short, because I'm running out of time. So if you could roll the video, please, gentlemen.
very, very warm welcome to the 8th Annual Nuclear Skills Awards. I'm delighted to see so many people here tonight.
A big thank you to all the organisations that have purchased seats for tonight, and of course our sponsors.
This industry...
Sorry, Tom. You've already heard from Tom, but I'd love to show you the whole video, but unfortunately we don't have time. But I just want to show you that that's just one of the ways that we are celebrating success. And the reason we're doing that in the UK, and I'm sure there are many such ceremonies around the world, and I know there are some happening at this event, is because we really need to collectively, working across borders, inspire the next generation. We really need bright young people to come into our sector. So in conclusion to this very short presentation, 3 key things that we're concentrating on in the UK: managing the skills and competence life cycle, celebrating success where we can, and inspiring the next generation. If you're interested in any of these ideas, please do come and visit me. I'm kindly hosted for this exhibition on the Bureau Veritas stand at B56. Got lots more to talk about, so please do come and say hello and see how we can help you in the future. Thank you very much.
Am I live? Yes, I am. Okay, thank you to all our speakers. Now, I saw a few of you nodding off then. No offense to our speakers. I know it's very warm out there, but believe me, if you think it's warm down there, you should be sitting up here. So this is audience participation time. You've got all of these experts lined up, and this is your chance to really maximize your presence here today by perhaps asking some of the burning questions that you want answered. From the regulatory side to industry to training, you've got them all here. Now, I'm suspecting if things go normally the same way, that probably you're all far too nervous and shy to put up your hand and ask the first question. But I've got a few questions to put to our panel. So while we're chatting, if any of you think of something or if something occurs to you, put up your hand and wave at me. Even though I'm from the UK, well, there's 2 of us from the UK, we're still friends. You can catch my attention and we'll get a microphone to you. So yes, as I said, perhaps if I can kick off, and I'd put the first question to you, if I may, Mark. We talked about new projects, the importance of new projects and so on. But with so many of these projects in the media and the political spotlight around the world, do the I won't say slippages, do the changes in construction and planning schedules in one country, do they increase pressure on other developers, on other projects in other countries? What's your view on that? You've had a little bit of experience of this in certain parts of the world.
I think I touched on it. We went through that process and some of the challenges we were having with delivery of some major components. They do, but I think what you ultimately realize, it's an evolutionary project. So, you know, we not only have to, at Westinghouse, have to deal with, as we went through this process with our partners and our customers in China and the US, you know, not only is there a communication issue you need to deal with externally, you also have to deal with our great parent company, Toshiba. These issues are internal and external. When you hear information at our project and what it means to the current projects and other projects. So it's always important to address the relevant pieces of information that are out there and try to put it in a proper perspective. You can't get overly emotional. There's a whole host of misinformation that goes on. We chose to react to the most important pieces of the information. And I think at the end of the day, we all know that when the units start up and they're running, we all know that our focus is that's the last memory. And that's the win. No one said the win was going to be really easy. you know, some of these schedules for the projects were based on not complete full engineering design in some cases. Those relevant facts are what the customer and the vendor chose to go into. It's not an excuse, it's a statement of fact, and I think others have dealt with it, that we were a little bit further advanced. But the reality is it's not only just an external issue you deal with for other projects. At the end of the day, we're now in a positive frame of mind, and we're moving the ball forward. And it's important to realize that's what we all wanted when we started these projects, to get through the first of the kind, so the next evolution of the projects would not be viewed as too risky by the financial investment community, which have really stayed on the sidelines for these, unless you're in a state-owned scenario, because they were a little gun-shy. So we're hopeful that the positive things that are going on will start to move some of the other projects, not only for us as we look at Turkey, we look at Bulgaria, we look at India, even more so. You know, you've all heard about the news in India. The movement in India, to be honest, was not a function of us giving PowerPoint presentations. They visited our sites. They said, I hear what you've gone through. You're getting ready to start a power plant. That's what they remember. And I think you focus to the end game and realize till you get to that point. So I think you can get to a point where you can bring the folks who have been waiting, you can bring them forward based on your recent success and be able to give them confidence that we don't envision you're going to have any of the first-of-kind experiences that we had as we went through these. You may have them in some site-specific issues, but the reality is that's what we're focused on. And I think at the end of the day, that's the most important thing you can ask for when you embark on a major project like this.
Tom, perhaps I can ask from your point of view, because you'll be building in the UK, a greenfield site even. How does this issue fit into NUGEN's planning, and how do you deal with it, particularly with the media responses and their reporting on things elsewhere in the world? How does that affect a project like yours?
Well, I think, as Mark said, we have to focus on the benefits and the lessons learned and the experiences of delivery that have been achieved in the AP1000 fleet. For NUGEN in the UK, the technology selection we've made with the AP1000 allows us to benefit from all those experiences. And therefore, we have to try and provide that narrative to investors, to lenders, to stakeholder governments who are going to invest in NUGEN to demonstrate that that has actually transferred into the standardized solutions and the knowledge that will be applied for a build in the UK. Now, there's still, on top of that, there's still UK challenges that have to be quantified and measured and mitigated. So there's many aspects that could affect the overall schedule, and it's important that we tackle each one individually and drill into the detail. There's a lot of data, a lot of experience from the 8 reactors that Westinghouse are in the process of building. When the first one loads fuel here in the coming months, I think that will be a massive milestone in the AP1000's journey. And all of that experience and knowledge builds into our program. I think having a reference plant concept and a standardized design enables us to have a really clear story around delivery certainty. Selecting the right partners in the EPC chain, selecting the right partners in the UK who've got a UK experience of dealing with productivity issues in the labour workforce and can demonstrate a responsiveness to the UK challenges is the other part of that, which has to also be factored into the equation.
Okay. When we started, I think, did somebody raise their hand in the audience? Is anybody else out there involved actually in building or preparing a new build project right now? Did I see somebody? I think it was a question. Was it a question that you asked, Bill? Was there somebody out there? You've either gone for a sandwich or you're very shy. It would just be interesting to get your view. How about investors? Have we got any investors out there or potential investors who are looking to get into nuclear? No? You're all either very happy with the industry right now or you're very shy. Bill, on that question, we're talking about the whole aspect of the political and the media impact and so on, and on investment. What can a regulator, as it were, do to, I'm not saying you should necessarily provide certainty, but what can you do to perhaps smooth the way for developers?
Well, I was very interested in listening to Mark's discussion about the experience with the AP1000. Of course, I was an NRC commissioner when that got started and was observing that very closely. And there were a lot of lessons learned during the construction. I think one of the comments from Mr. Zhou was actually, I thought, very good. That, and I don't remember the exact quote, but there was something about an orange planted in the south. If you plant it in the north, it may not be as sweet. Something to that effect. There is clearly an advantage to building multiple plants in the same environment, and you learn a lot very quickly that you can apply to the next plant. Your workforce becomes smarter. Your subcontractors work out their issues, and I think it's also the same with the regulator. And it's very clear to me that during the initial construction of the AP1000s in the United States, that the NRC was learning about its process as much as Westinghouse is learning about how to build a reactor. And there was clearly probably a good year and a half or so while the bugs were worked out at both sides. And quite frankly, there was a lot of surprise on both sides about how the process actually worked, and we had to figure out how to go forward. So I think that the regulators suffer from some of the same issues as the industry in terms of experienced people who have been through this before, that know how to manage the environment, to know how to work with the industry on a large, complex project. And there's a learning curve to that. So I think that the regulators' job, of course, at the beginning and at the end, is to assure safety, but they have to do that in an efficient manner. And the best way to do that is to have experienced people. And so I think regulators, as they embark on these projects, and I think in the UK this is a very good case in point, they really need to find ways to get their people the experience necessary so that they can make the right decisions when the time comes.
Talking about the workforce and so on and the skills they're doing, I suppose I've got to come to you. Of course, the UK is not the only country that is building or wants to build. And of course, you touched on this in your presentation. How important is getting the right people in place at the right time to these guys who are going to go out and find the money and want to build? What can you do to help with that?
Thank you, John. Yes, it is vital. I did touch on the challenge of doing that. We've been monitoring and predicting and forecasting the sorts of numbers of people that we'll need to build the new power plants, as well as obviously keep the ones that we've got functioning, and then there's a decommissioning supply of skills as well for that market. So the good thing that's happened recently in the UK is that the developers and the government have come together to form a new nuclear skills strategy group in order to find the clarity around the demand for skills and when that is likely to be, and what the supply chain is likely to see coming down from those big projects. So I think it's incumbent on us receiving that information to put the programs in place to meet the needs, both in terms of quantity of people, but also in terms of quality of people. And I'm pleased to say that that is happening. I mentioned the announcement of the new National College for Nuclear. This is going to be a very exciting initiative for nuclear. Colleagues from the National College are here at this event in the training planner area, so do go along and see them. So we're not complacent. We realise in the UK it's going to be challenging for us as these projects converge, and there is demand for construction skills, for example, from other major infrastructure projects across the UK. But we've been working on this for at least 10 years, and we have a very clear view of what is required and when, and we can turn the training supply pipeline on, but we don't want to do that too early and lose the skills that we've developed to other sectors and to other projects. So it's a fine line, and I'd be interested in others' views on treading that line.
Does anybody have any points on what we've discussed so far? Anybody have any particular comments to make? Any nuclear trainers in the room? No? People who have just graduated in nuclear looking on? No? Oh, they're ever so easily pleased, this crowd, aren't they? I tell you, we found one. Yes, sir. Oh, don't be shy. Let's get a microphone. Could you start off by telling us who you are and where you're from, please?
Yes, my name is Gil Grady with GSE Systems in the U.S. I'm not a new nuclear graduate, a little bit different question. What I'd like to do is kind of bridge one of the sessions this morning where we talked about the nuclear promise in the U.S. and the need to drive cost out of operations. And I guess I'm kind of curious for Mark and Bill, kind of what's the role of the supply chain and the new build companies and the regulators and kind of helping the industry drive those costs out or build that nuclear promise into the design of new plants?
Okay, let's start off with either of you two, and then I'd also like to bring in Scott as well, but please, yeah?
Well, this is not exactly an unpopular question, as you might imagine. This is something we hear quite often. And it's a difficult, when you ask that question of the regulators, it poses a lot of difficult questions because regulators, by nature and by training, are told, don't worry about the costs, worry about the safety. And your job is to focus on the safety. That said, I also think that regulators have the tools to avoid making unnecessary regulatory decisions. I think that the use of, particularly in the U.S., the use of probabilistic risk assessment has been very successful in helping the regulators focus on the things of highest priority and not worrying about things that have very little safety impact, but yet may cost a lot of money. So just because something's expensive doesn't mean it enhances safety. So I think it's something the regulators around the world have to give some thought to, however, whatever methodology they use. But I think that the best thing that all components of the industry can do to reduce costs is to apply analytical tools that they have at their disposal to take advantage of, for example, if you're building new components, to take advantage of simulation tools to make sure that you're designing something right the first time and that you don't have to go through rework. You know, we were listening to this story about the steam generator or the steam dryer replacement. Those are the sorts of things you would like to think that we have the tools to prevent those sorts of mistakes from happening. So I think that doing things right the first time, both on the regulatory side and on the industry side, is really the best you can do. And I think that if in the case of the owners, I think the owners, and this is a big mistake I think that was made in maybe in the early stages of some of the projects in the U.S., the owners thought they could kind of stand back and watch the magic, and they learned as they went that they had to be deeply involved in everything that was going on. And I think that is something the owners can take responsibility for, not assume that all the contractors and subcontractors know what they're doing and will come out with the right answer at the right price, but to really be involved and be watching and give careful oversight to make sure that they're getting the value for their resources that they're put into the projects.
Mark, quickly, briefly.
Briefly on new plants, and then maybe turn it over to Scott a little bit on this nuclear promise. You know, from our standpoint, I think the most important thing we learned, and I think, honestly, I think at the end of the day, the industry benefited from it in the U.S. specifically for sure. Our supply chain was not ready, okay? And our supply chain challenged with 4 nuclear power plants. There was a scheme at one point in time that there was going to be maybe over 10 or 12 being built at the same time with 3 different reactor designs, depending when design certification was going to be ready for those reactor designs. I think, although I wouldn't say it was desirable that we got to learn first from Westinghouse on the AP 1000, but we did. And some of our challenges were, as Bill mentioned, I'm glad he mentioned it first, we had some challenges on the regulatory front, how to implement. We had some challenges on the supply chain front. We had some challenges on getting design complete and finalized, and we worked through those, but it was a little bit more painful than necessary. I think at the end of the day, what we end up with now is a standard plant design, and we have a supply chain that, let's face it, we went through some changes in the supply chain. Some suppliers couldn't make it. They fell into financial issues. Some stuck with us through there. We're willing to work and be innovative commercially to keep these projects moving forward because they're looking for the next unit, either to support an export work overseas or any of our other new plants that are customers that are looking at it. So I think that's really important. I think what's even more important about the nuclear promise is the nuclear promise that's going on in the U.S., and I'll let Scott describe it because it's really driven by the NEI, but we participate as a vendor. It's about how to optimize and reduce costs of the output of the current reactors. I spend 80% of my time worldwide supporting the operating fleet from my standpoint, and very much involved in what's going on there. And where the vendors can support right now is around innovation of new projects, coming out with new products and services that will reduce the cost of outages, reduce the cost of maintaining that plant, or reduce capital projects for them, because it's a critical issue right now. It's also now an issue to almost the same extent growing in Europe. Power prices have fallen, the economies have changed, Germany is off doing what they're going to do, but the reality is we have a challenge around the cost of our reactors, and there's a significant amount of effort going on in NEI, but our main component right now is focusing on innovative products. We've developed innovative projects around steam generator inspection, which have reduced outages, and those are the things that we're focused on from the operating plant. But I think Scott would be appropriate to talk about it because we're supporting them at this point in the evolution of where the utilities are going, so they don't have to announce any more potential or real retirements.
Somebody already mentioned there was a session this morning on the nuclear promise. I don't know how much detail that session went into, but I'm personally heavily involved with the nuclear promise in the United States. I'm leading up all of the engineering activities, and I will tell you it is very exciting. Getting to a 30% cost reduction at our existing nuclear fleet is going to be challenging. I think we'll get there at some of the units, may not get there at some of the other units that have already done a lot of cost optimization. But we're doing things that are probably going to even benefit some of the new build. Like, for example, what we're doing is we're going to create a standardized design process so that everybody does a modification to their plant exactly the same, which immediately reduces costs if you use vendors. Because your engineers of choice don't have to know multiple modification process sessions. I'm not doing that, am I? Okay. So that'll reduce cost when you're using vendors, and the goal is going forward is we'll be able to share all the modifications in the industry. So if I do a modification at one of my plants, then Entergy or Southern Company can take that and actually replicate it and save costs there. So a lot of interesting things going on. Big areas for us. We talked about working with the regulator. Big challenges with our regulator in risk-informed regulation. You've got a lot of folks, including the leadership at the Nuclear Regulatory Commission, very much wanting to move forward with risk-informed applications, whereas the staff are somewhat resistant. So we are working to, train the staff on what does risk-informed mean, that it really does improve the safety of our nuclear plants while reducing costs. And I would say the biggest one, and again, it should benefit the new reactors too, is something called 10 CFR 5069, which has been on the books forever. And for whatever reason, we haven't adopted that regulation at most of our sites, but it allows us to classify the quality assurance controls on every part in our plant based on the risk significance. So the costs go down dramatically because there's only a small subset of parts that really need the highest level of quality assurance.
Were you raising your hand to me? No, clearly not. No. I did see something. Yes, I'm sorry, sir. Yes. Tell us while one of our helpers is running towards you. There you go.
Thank you, gentlemen. My name is Hash Hashemian. I'm from AMS in Knoxville, Tennessee. The question for Scott Greenlee. My question is, how much did that 300 megawatt power uprate cost? Question number one. And two, how many more reactors are we going to lose in the United States in your estimate?
Wow, that's okay. The first question's easy, around $800 million for the 300 megawatts, so a pretty good deal there. The how many more nuclear plants are we going to lose? I don't know that my crystal ball is good enough to tell you that exactly, and I'm probably not as knowledgeable about the other utilities. I will tell you that I am an optimist. I see every day, I see environmental groups and others recognizing that shutting down nuclear power plants is not going to change the climate change equation, and if you believe and care about climate change, nuclear has to be there. We have to have these nuclear plants. Like I said, we announced shutting down 3 nuclear plants recently. One of those nuclear plants, Fort Calhoun, absolutely is, they're not going to operate that plant, so that's a given. The 2 we announced, Clinton and Quad Cities, there's still a chance that the Illinois legislature could turn around and actually enact carbon legislation. We just don't know at the moment. I'm very optimistic about the state of New York enacting carbon legislation to keep the upstate New York plants, exception of Fitzpatrick, operating. And I think we're going to start seeing, as New York's probably the nearest term, as New York puts together their policy and approves it, I expect that the other states are going to follow. So I'm optimistic that we're going to, we're not going to lose as many power plants as people would probably project right now just based on the economics, because I think the states are going to wake up, with maybe the exception of California, on carbon legislation.
Thank you. Time is almost caught up with us, but I would like to ask my colleague here from China. Fang, you work in research and design. How much of your work is being influenced right now with by companies overseas, or the pressures of the Chinese market in developing reactors? What's your work involved at the moment? Yes, what kind of work are you doing with overseas firms, for example, in research and design? Is there much cooperation? And you have to use your microphone so they can hear you. Yeah, do you have much work with overseas?
Not so much. Yeah.
How much does the Chinese regulator involve itself in your work?
In China, and we most cooperate with the NSA, the nuclear audience, the bureaucracy. And for another things, I think in China the situation may be a little bit different. In China, the nuclear industry is totally guided with the government, and for the to convince the public, also we need to make sure that the nuclear power is a safety and green energy. So when we do the project, the NSA will deeply involve the project, including the supplier chains. And
do you pay close attention to projects overseas to see how they evolve, how they develop?
Not too much.
Not too much, no, because you're building so many on your own, I suppose.
Yeah. There's a rapid developing in China for the nuclear industry, and we just start to focus on the overseas project, okay. But not experienced.
Let me ask, because we're coming into the final minutes, but if you will indulge me with a question from the UK, how soon do you think we could see Chinese design built in the UK or anywhere else in Europe, for that matter? I mean, you're thinking of the Chinese design reactors. We have a possibility of one being built in the UK. Do you know how long? What's the time scale for that?
I think we will meet many challenges, because the UK, the situation of the UK is totally different in China.
You can say that again.
Yeah.
Yes. Okay. Before I close up, has any member of our audience have a final question they'd like to put to any of our panel or panel in general? No? Well, I think, gentlemen and lady, that we've probably all borne the heat of these lights for long enough, and I'm also pleased to say that we're finishing, I think, virtually on time, which gives you all and the audience a chance to go and get a coffee. So may I invite the audience to thank our panel of experts, and thank you for being with us as well this afternoon.